Let's take a look at the random method of the math class. It is an extremely powerful method, but we have to tweak it a little bit to get it to do exactly what we want it to do. And in this example, I want to show you what I mean. And so what I've done is I've used the random method 3 times, and let's see what it would output. It generates a random number between 0 and 1. The 0 is inclusive and the 1 is exclusive. And this is actually not very useful to us. There are very few real world situations or scenarios in which you would want a number between 0 and 1. Have you ever asked your friend, hey, pick a number 0 through 1? They would have an almost impossible time figuring it out. So as I said, we're going to tweak the random method to get it to return more palatable results. And one way that we could do that is we can multiply it times a number. And in this case, I've chosen the number 10. And look what happens to the output when I multiply it times 10. Instead of giving me a range of 0 to 1, it gives me a range of 0 to 10, with the 10 being excluded. And the output could look something like this. Now, this is not very useful to us, but we're getting closer. And let me show you the advantage of what we've just done. When I take the results and multiply it times 10, I could get an output like this. Now, you're probably saying, well, that's not all of the possible outputs, not even close. Well, you're correct. But what I have shown are all the possible outputs for everything in front of the decimal. And why is that important? Because what if I were to take off the decimal place? What possible outputs could I get? Well, it would be the integers 0 through 9. What I want to do then is lop off the decimal. I don't want to round up. I just want to take off that decimal and use only the integer values that I find. Well, how could I do that? I could typecast. And when I typecast it, something interesting is going to happen. I'm only going to be able to have a possible output of 0. And this is a common mistake with people first using the random method. The problem here is a problem of order of operations. First, it's going to find a random value, which we want it to do, but then it's going to typecast it. And when it typecasts it as an integer value, it's going to take everything after the decimal place and remove it. So we would get 0 every single time. When we take 0 and multiply it times whatever number is there, we're still going to get 0. So do not fall into this trap or this error, and the simple solution is to add parentheses. So when we add parentheses, it's going to multiply by 10 first and then typecast the result. And now our possible outputs are far more palatable. We have 0 to 9. One thing that we can garner from this is this value right here is going to be the amount of possible numbers. You'll notice that 10 is not included in there, but we have 0 through 9, and those are 10 values. So when you see Math.random times a number, whatever that number is going to represent how many possible outcomes can I have when this operation runs. There is one more thing that I'd like to show you and tweak about using the random method. If you look here, no matter what number that I would put to multiply by, I'm always going to start at the number 0. And most ranges that we use do not start at 0. So let's see how we can have a minimum value. And let's define the problem further. So let's say that you're playing a game, and the point of the game is to hit things with whatever stick you have. And you start out with just a normal everyday stick. And it does a random damage of 1 to 10. And then as you play the game further, you get a random range of 5 to 15 with your nightstick. And then finally, you get a lightsaber, and it can do 50 to 99 damage, depending on what the random range generates in order to win the game. And what do you notice about all three of these things? None of them start at 0. So I just wanted to show you that it is common not to start at 0 and show you an interesting example of why it is important to be able to make this last tweak or start some other value than 0. So we have the example from before, and we're going to make one tweak to it and add 20. So what it's going to do is it's going to find a random value, multiply it times 10, typecast it, and then add 20. So this value out here is always going to be the minimum value, or what is called the lower bound. And this value here is still the amount of possible numbers. Well, what are we missing? What we're missing is the upper bound, or the maximum number. And we have to do a small amount of math in order to get there. But before I show you that math, what I want to impress upon you is, do not look at someone using Math.random and see, oh, this is a range of 10 to 20. I cannot tell you how many beginning programmers do this and completely miss what is going on and get the range completely wrong. So what I've done is I've given you two possibilities of what the range can be, and I've expressed them how I've been expressing them thus far in the slides, as 20 inclusive, 30 exclusive, or from 10 to 20. And I think I've simplified it in a range of 20 to 29 or a range of 10 to 19. Now what would it be? Pause the video for a second and see if you can figure it out. Well, the correct value would be 20 to 29. And so that is not obvious from looking at here. And one thing that I want to show in this video or impress upon you is you cannot look directly at the numbers and assume that that is the range. This number outside of here, yes, that will be part of the range. That's the minimum, or what we call the lower bound. But the upper bound is nowhere to be found. We're going to have to do some math in order to find it. And let's see what that math is. So what I've done is I've shown you a whole bunch of examples using the random method. And there are really two ways that you can use Math.random, or you'll find Math.random. And that is, one, if you're looking at someone else's code, and this would be the case right here. I'm giving you this method call, and I want you to determine the range. And then later on, we're going to start with the range and figure out what to put inside of the method call. If you're moving from a method call and converting it into a range, it has a simple formula of add the two numbers together and then subtract 1. But before we do that, we can already put some values over here inside of our range. We know that the numbers on the right here are all minimums. 10, 10, 32, and 845 are the lower bound of our ranges. The only value that we have to find using math is the upper bound, or the maximum. So we're going to look at the first example here. Take 100, add 10, exactly as it's shown, and we get 110. Subtract 1, and then we get 109. And that 109 is going to be our maximum or upper bound. So the correct range for 100 plus 10 would be 10 to 109. In the next example, we would take 101, add 10, and we get 111. Subtract 1, and we get 110. And so our range would be 10 to 110. The next example, 55 plus 32 is 87, minus 1 is 86, and so the range would be 32 to 86. In the last example in this set, I just wanted to add a larger number, so I started with 845. So we're going to say 13 plus 845 is 858, minus 1 is 857. So the correct range would be 845 to 857. Now let's look at the next three examples. You'll see that two of them are missing the plus sign afterwards, and the one that does have a plus sign has a 0 at the end. And I've done this on purpose just to show that sometimes you don't have to express the minimum. If the minimum or lower bound is not expressed, it's going to be assumed to be 0. So let's see how this plays out. We can put the zeros in our range on the left-hand side over here, because we know if no value is expressed or it is expressed as 0, we could put the minimums right here. Now, let's see how this plays out. In the first example, I don't have plus 0, but I know if there is no plus or minus anything, it is going to be 0. So I'd say 10 plus 0 is 10, minus 1 is 9, so the correct range would be 0 to 9. The next example is almost identical, except for I have the plus 0 explicitly stated. And it's the exact same math, so I'm going to put the maximum or upper bound as 9. The next example, we would have 33. Plus 0 is still 33, minus 1 is 32. So our range would be 0 to 32. Let's look at the next three examples. And in those, I've used negative numbers. And just like we've done before, we can already lay out our minimums. And our minimums are negative 20, negative 80, and negative 10. And so we have put them over here, negative 20, negative 80, negative 10, and we're going to look at the first example. We're going to do what it says. 10 plus a negative 20 is going to give us negative 10. Minus 1 is negative 11, so the correct range would be negative 20 to negative 11. And remember that you're working with negative numbers, so do the correct math accordingly. Next, we have 40 minus 80, and 40 plus a negative 80 is negative 40. Minus 1 is negative 41, so our range would be negative 80 to negative 41. And the last negative example is interesting because we're going to go from a negative number to positive numbers in our range. And let's see how this works. We take 30 plus a negative 10 is positive 20, minus 1 is 19, and so our range is negative 10 to positive 19. And I've thrown in this last example because I find it interesting, because it is the only case in which you can look at the two numbers there and know exactly what the range is going to be without doing any kind of math. And let's see what I mean. 10 plus 1 is 11, minus 1 is 10. When you're adding 1 and then you're going right back and subtracting 1, you're going to get the number that you started out with. So in this case alone, this value right here is not only going to act as the amount of possible numbers, it is also going to be the upper bound. So hopefully you feel comfortable finding what a range is going to be using a method call. What I've done in this slide is given you the opportunity to try it out for yourself. I've given you a bunch of ranges similar to the last slide, and you can pause the video here and try to figure out the ranges. I'll come back on and show you what the answers are to this in just a sec. Okay, I'm going to show you the values, and the correct values look as stated. Now, let's say that we wanted to, instead of starting with somebody else's code or looking at a range and trying to figure out what the method call is showing us and converting it into a range, I want to give you a range and have you be able to put it into code. And so that's what these examples are going to be. And the formula to do this is to take the upper bound minus the lower bound and then add 1. But before we do that, what do we have sitting there on the left-hand side? We have the minimums. Can we plug them in directly without doing any kind of math? Absolutely, and that's absolutely what we're going to do. We plug in the minimums, and now let's look at the first case and find out what value is going to go inside the parentheses there. We would take 109 minus 10, or the upper bound minus the lower bound, and we would get 99. Then we're going to add 1, and that's going to give us 100. So the number that's going to go in the parentheses there is 100, and that is a range of 10 to 109. In the next example, we take the maximum value, which is 110, subtract the minimum value, which is 10, and we get 100. Add 1, and we get 101. In order to get a range of 10 to 110, we would use the number 101 plus 10. Next, we're going to try to get a range of 32 to 86. The upper bound is 86 minus the lower bound, which is 32. We get 54, add 1, and 55 is the value that goes inside the parentheses. Lastly, in this set, 857, which is the upper bound, subtract the lower bound, which is 845. We get 12, add 1, 13 goes inside of our parentheses. Next, if we're looking for a range of 0 to 9, well, we could put 0 as a minimum on the outside and say plus 0, but it's not necessary and it's not common to do that. So the math would look something like this. 9, which is the maximum, minus 0, which is the minimum, gives us 9, plus 1 is 10. So the value that would go inside the parentheses is 10. And I'm doing this exact same thing, but you could probably guess what I'm going to do, and I'm actually going to add the minimum. If you need it as a safety net, you can certainly put it there, but it's not encouraged. It would be the exact same math, and 10 would still go there. So 0 to 9 would still be our range. If we have 32, you take 32 minus 0 is still 32, plus 1 is 33, and so we would put 33 in the parentheses. The next three examples, we want to do negative examples, and we have the minimums. So we're going to display them inside of our method calls. Now let's look at the first case, negative 20 to negative 11. Now remember with negative numbers, negative 11 is greater than negative 20, so you put the upper bound on the top and the lower bound on the bottom. And then when you subtract them, if you're subtracting a negative 20, that's really going to be adding. So it would say negative 11 plus 20 is 9, plus 1 is 10. And this value here is always going to be positive because it's the amount of possible numbers in the range. You could never have a negative amount of possible numbers in the range. In the next example, we have negative 41 minus a negative 80, which is 39, plus 1 is 40, and that is what will go inside of the parentheses there. In the next example, we have 19 minus a negative 10, so we would add 10. We get 29 plus 1 is 30. So the number that would go in the parentheses is 30. And then in the last example, it's the special case again of 1 to 10. We could put the minimum there of 1. And if we're going to subtract 1, get 9, add 1, get 10 again, 10 would go inside of the parentheses. And again, this is a special case where what the range is going to look exactly like this over here, except for we have it reversed. You would have to read it 1 to 10. I've given you an opportunity to try it for yourself. I've given you all of these different ranges, and if you can do the math, pause the video and see if you can find what the correct answers are. I'll give you a sec, and then I'll come on with the correct answers. The correct answers would look like this, and hopefully you now feel comfortable starting with a range and plugging it into source code in order to find any type of random range. One last example that I'm going to share with you. I'm going to start with 26 plus 65, and let's see what this range would be. It would give us 65 to 91 with 91 not being inclusive, or 65 to 90. It might seem like a random range, but it's actually going to give us some interesting results if we tweak it in one small way. And let me show you what that is. I'm going to add parentheses around what I just did, and the parentheses are indicated that I've added in red here, and I'm going to typecast it as a character. And when I do that, instead of giving me a range of 65 to 90, it gives me a range of capital A to left bracket non-inclusive, or capital A to capital Z. So if I was to run this program right now, I would get a random letter between capital A and capital Z. And the reason is that this range right here is the ASCII equivalent of capital A through capital Z. And you might be cued off by the fact that this value right here is 26. There's 26 letters in the English alphabet, and there are also 26 values in my example here. In the next example, I've done it slightly differently. I've stored the value as an integer value, and this would give us a value between 97 and 122. And when we print it out, we're going to typecast it. It would give us a value between lowercase a and lowercase z, so it might give us lowercase q. So this is just an interesting way to use the random method to find a random symbol, letter, character, whatever you're trying to find using its ASCII value. All right, let's sum up this big random method. The random method has a simple purpose of finding random numbers. By itself, it is unimpressive because it finds a range of 0 to 1, with the 1 being exclusive. And this range is almost infinite, and it's absolutely not useful. So we have to tweak it in a few ways to get numbers that we can actually use. So first, we're going to multiply it times what the random method returns by a number like 10. And so 0.872 would become 8.72. And then we want to get rid of that decimal, and we do that through typecasting. So we typecast it as an integer, and that gets rid of, in this case, of the 0.72, and we would just have 8. Now, if we were to stop there, we could only have values between 0 and some upper bound. Well, what happens when we want to have a minimum? It's simple to do. All we have to do is add a value at the end, and that is going to be our new minimum instead of 0. When someone has given you code and you're trying to convert it into a range, the way that you do it is you add the two numbers together and then subtract 1. And if you want to do it the opposite way of someone giving you the range and then you convert it into a method call, you're going to take the upper bound minus the lower bound and add 1, or the maximum minus the minimum, add 1. And then lastly, we showed you how to generate random letters using the random method. You simply find the numbers in the ASCII range and then typecast them as a character. The random method is extremely important to many programs, and it's important to understand exactly how it operates. Be sure to know that when you look at a range on a computer, it is not giving you the lower bound and upper bound at the same time. It is only giving you the lower bound. You have to calculate the upper bound. The math is not hard, but it is required in order to find the correct values. Make sure that you're calculating the values correctly and you will get the correct range that you're looking for. Mastery of the random method will certainly help you in your programming endeavors.